welcome guys. Before us we have a question in physics under the topic of waves. Now a wave is just a disturbance that carry energy from one position to another position. Now we usually deal with two types of waves, which is the first one, we have transverse wave and longitudinal waves. Now if you look at the question, so the question reads figure B 5.1 shows transverse waves. So we are dealing with a transverse waves. Now, how can you identify or how can you tell that the given wave is a transverse? Because sometimes you may be given a question where you're told to what type of wave is shown. So how do you know that this wave is a transverse or a longitudinal? So there are two factors that will help you to determine the type or the nature of the wave given. So the first one is the direction of the wave. So you need to observe in which direction is the wave moving to. Then the second one is the vibration. So if we say we have the XY plane, so if the wave is moving in the X direction, X-axis direction, then the vibration of particles are vibrating in the Y-axis direction, then the wave that we are dealing with is a transverse because the angle formed between the direction and the vibration is 90 degrees. So as long as the angle is equal to 90 degrees between the vibration of particles and the wave, the direction of the wave, then the wave that you're dealing with is a transverse. So to summarize our answer, our definition, we say a transverse wave is a type of wave in which the vibration of particles are perpendicular to the direction of wave. So that is what you have to use. So as you can see, the wave is moving in this direction, then the vibration is like this. So the vibration is in the y-axis direction. So that's why we are saying we are dealing with a transverse wave. Now from there, we have question A, where we are told to find the number of waves in figure B 5.1. So if you look at the number of waves for this one, we just have to count according to the diagram. So now how do you count the number of waves? So this part here, this peak, is considered to be the half plus this. So this makes one wave, then this 2 waves, 3 waves, 4 waves. So we have 5 number of waves in total. So this is how you are supposed to count the number of waves if you encounter a question like this. So we'll say 5 waves. We move on to question B. So question B is, what is the amplitude of the waves generated in the figure above? So the amplitude is just the maximum distance or the maximum height the wave can reach from its rest position to its peak. So the rest position is, this is our rest position. So it's like the origin, the point where the wave will, the vibration of particles are starting from. So if the particles are starting from this and they're able to move up to here, so this is the highest point the particles are able to reach, then the distance from here up to here is our amplitude. So you just have to get the number that you have here. In our case, we have 5 meters as our amplitude. So as you can see, it is very simple. So we are dealing with 5 meters. Now we move on to question C. Calculate the speed of the waves above if the number of waves in figure B 5.1 are produced in 2 seconds. So we have 2 formulae that we can use. The first one, we can use speed is equal to distance over time taken. or we can say speed or velocity is equal to frequency multiplied by lambda. So let's see if we can find the same answer. So let's begin with this one. Speed is equal to distance. So the distance, we need to look at what was the distance covered by the all 5 waves. So the distance will be measured from this point, since we are dealing with 5 waves, up to the last point here. And as we can see, this distance is given by 6. So the distance in total is 6 meters. So that is what I'm going to put here. So distance is equal to 6 meters over time. We are told it's 2 seconds. And in case you are given time in minutes, please don't forget to change into seconds. So we have 2 seconds, which tells us that 2 into 6 is 3 meters per second. So which means that per second, for 1 second, a distance of 3 meters was covered, and it's making sense. So let's look at where 3 meters is. So this is our 3 meters. So the from this point up to here, the distance is 3 meters. Then from this point up to here, the distance is 3 meters. Then the total distance is 6 meters. So from this point up to here, where we have 3 meters, it took 1 second. Then from here up to here, it took another 1 second. Then the total number of seconds that were taken were 2 seconds. So let's hope you are getting the concept here. So that is the speed. Now let's say if we want to use the other formula, can we get the same answer? So let's give it a try. Now for us to find the same answer, I mean the answer using this formula, we need to find the frequency. Then after that, we are going to find the lambda. So the lambda is just the wavelength. The wavelength is the distance covered by one complete wave. Then frequency, we are looking at the number of cycles produced in 1 second. So how can we find this? So let's begin by finding a period. So period denoted by capital letter T is equal to small letter t over number of oscillations. So t denotes the time that we were given. So we are given 2 seconds. So where there is small letter t, we put 2 seconds over n denotes the number of oscillation, which is 5. So if we divide 2 divided by 2 will give us 0.4 seconds. So which means that each complete wave took 0.4 seconds. So now if we can find period, can we use period to find the frequency? Yes, we can. So we're going to say frequency is equal to 1 over t. So that's the formula, which is 1 over 0.5. So if we divide 1 by 0.4, I'm getting 2.5. So 2.5 hertz, which simply means that in 1 second, 2.5 hertz, which is the number of waves were produced. And it's making sense. Remember, we said the total time taken for the 5 waves to be produced were 2 seconds. So from this up to somewhere here, 2.5 waves were produced in 1 second. Another 2.5 waves were produced in another second. And if you add this 1 second plus this 1 second, we have the total number of 2 seconds. And if we add 2.5 plus another 2.5, we have the total number of waves that were produced. So if we have this now, we can go back to our formula. So frequency is 2.5. Now if frequency is 2.5, what is the lambda? So the lambda is the distance for 1 cycle. Now, how can we find the distance for 1 cycle? So we're going to do this. So say lambda is equal to, the total distance is 6 meters. So this is our total distance. over the number of waves. We have 5 number of waves, so we want to divide the total distance by the number of waves so that we can be able to get the distance for one wave. So 6 divided by 5 will give us 1.2 meters. So 1.2 meters is the distance for one wave, so we put 1.2 here. So we just have to do some math. 2.5 times 1.2, so I'm getting my final answer 3, which is the same as 3 meters per second. So as you can see, we are getting the same answer. So if you have understood my concept, you can use any of these concepts. Then before we end our lesson, we can also find frequency by looking at the reciprocal of this, where we put n on top over t. N is the number of our oscillation, which is, we say it is 5, over time is 2, 5 divided by 2, we still get 2.5 Hz. So this is how we can answer the question like this. So that's it for this video. Thanks for watching.